Okay, this is section 9.5, and I'm going to go through the entirety of the notes, so this will be a little bit longer video, but please feel free to go ahead and fast forward if you have part of the notes that you already have. Okay, so before we multiplied a vector times a scalar, and now we're going to multiply a vector and a vector. There are two different ways to do this. One is to multiply the two vectors and get a scalar quantity, which is going to be the dot product, and then to multiply the two vectors and get a vector product, and that's going to be the cross product. So it's a little bit different for each. This one is going to be the easier of the two, which is our dot product. So essentially what we do with the dot product is we take both of the a values of our vectors and we multiply those together. And then we're going to add those to the b values of our vector. So you'll notice that here it has our a values that we multiply together and then our b values, and then we add them together for v times w, or v dot w. All right, so let's go ahead and take a look at 2 so that we can put this into practice. We have 2i minus 3j, and w is equal to 5i plus 3j. So what we're going to do is set our equal sign here, and I'm going to put my like terms together. So I'm going to do 2 times 5 plus negative 3 times 3. So that's going to be 10 plus negative 9, and that's going to give us a value of 1. So v dot w gives us the value of 1. Now w dot v, I'm sure you can imagine we're just changing the order of these, so it shouldn't really matter all that much, but let's go ahead and go through it. We have 5 times 2 plus 3 times negative 3. Again, we're left with 10 plus a negative 9, and that gives us 1. So what we realize is that the commutative property is good, right? So forwards or backwards, we're going to get the same answer. Let's take a look at a vector times itself. So this is, we have 2i minus 3j, so that's going to be 2 times 2 plus negative 3 times negative 3. So that will be 4 plus, we have 9, and that's going to end up being positive. So we have a value of 13. Now let's take a look at w dot w. So 5i plus 3j, that will be 5 times 5 plus 3 times 3. So we get 25 plus 9. That gives us 34. Okay. And then the last piece, it wants us to find the quantity or the magnitude of each of those vectors. And we've done that before, right? So to find v, I'm going to take the x squared plus y squared. So that's going to be my I value times my I value squared times my j value squared. So that's 2 squared plus negative 3 squared. So that's going to give us 4 plus 9. 4 plus 9 will give me 13, square root of 13. And then w is going to be the square root of 5 squared plus 3 squared. So that will be square root of 25 plus 9. It's the square root of 34. So notice something interesting about this. So v times v gave me 13, and just the magnitude of v is the square root of 13. So if I did v squared, it would equal v dot v, right? So if I took this value and I squared it, I would get the same as v dot v. And likewise this one, if I took w and squared it or multiply it by itself, I would get w dot w, right? Because square root of 34 here, and then I have 34 right here. Well, now that we've been through that, let's take a look at some of those properties that we just talked about. One was the commutative that popped out. So it doesn't matter if I take u vector dot v vector or v vector dot u vector, I'm going to get the same result. That was just like these first two, right? V came first on this one, W came first on this one. Both of them had the same result. The other piece that we can take a look at is the distributive property. So if I had a vector that was in a dot product with two other vectors that are being added, I would just distribute this one as a dot product across both of them. And then we showed you this one, that a vector times itself is going to be equal to the square of its magnitude. And then, of course, 0 times any vector is going to give you 0. All right. Here is the proof that shows you how to get the vector or the angle between two vectors using the law of cosines and some algebraic manipulation. So I'm going to let you go ahead and take a look at that. But in the meantime, we're going to focus our energy and time on how we get this value right here. So here's our angle between vectors. This is what comes out of all of that. So for those of you that have me and are used to our magic triangle route, we have our option here of writing out this in a format that we can look for. If we want to find the magnitudes multiplied, we can take the dot product divided by the cosine of the angle between them. If we want to find the cosine of the angle between them, it's the dot product of u times v over the magnitude of both of those vectors. So let's go ahead and take a look at this, and we're going to do some example problems, right? So we had cosine of theta is equal to u times v over u times v. So I'm copying that over here. So of course, if we're finding our cosine, or if we're finding our angle, that would be the inverse cosine of u times v over u times v. All right, let's walk through this a little bit. First, we've got to determine what this u times v is. So we want to go ahead and map that out. So u times v, just like we did before, that would be 4i, right, 4 and 2 times 2 plus negative 3 and 5. Negative 3 and 5. So that's going to be 8 plus a negative 15. So that will give us a value of negative 7. Okay, negative 7 is what we get. And then the next thing we want to do is find the value, magnitude of u. And we know to find that, we take the square root of 4i minus 3j. So it's going to be 4 squared plus negative 3 squared. So that will be 16 plus 9, which gives us square root of 25. So we have 5 as our value there. And then to find v, we're going to take the square root of 2 squared plus 5 squared. So 4 plus 25 is going to equal the square root of 29. All right, so now we have both of our pieces here. So solving for theta, let's go ahead and put all of these pieces into play. All right, so my angle is going to be the inverse cosine of u times v is negative 7 over the value of u, which is 5, times the value of v, which is the square root of 29. Okay, So when I go ahead and figure out this value, okay, that value is going to be negative 0.26. I'm going to do that on my calculator. And then to take the inverse cosine of that, I'm going to end up with a value of 105 degrees. So that would be the angle between them. And we can go ahead and